Hello, grade 8 students. Welcome to our video discussion for Science 8, Quarter 1 Prelim, Lesson number 1. For today, we will be discussing about the Newton's law of motion. So before we start, let's take a look at the lesson's objective. Number 1, investigate the relationship between the amount of force applied and the amount of the object or the mass of the object and the amount of change in the object's motion or what we call to its acceleration. Number 2 is to infer that when a body exerts a force on another, an equal amount of force is exerted loop back onto it. And number 3 is to apply the Newton's 3 laws of motion. So let's begin with the Newton's 3 law of motion. Law number 1 is the law of inertia. For Newton's law of motion under law of inertia, the main idea of law of inertia is that an object at rest will remain at rest unless acted on by an unbalanced or by an external force. So it simply means that an object at rest will remain at rest. Okay? So it will not move unless there is an external force added onto it. Just like in our example here. So the ball is, in the first illustration, the ball is at rest position. So when someone kicks the ball will move. But if no one will kick the ball, therefore the ball will stay and the ball will not move. Okay, so that is Newton's first law of motion. So vice versa or the other way around, an object in motion will continue in constant and in speed direction unless acted on by an unbalanced force. Okay, so always remember that Newton's law of motion, an object at rest will remain at rest unless there is a force applied onto it, while an object in motion will continue and will never stop unless a force is added onto it. Okay? So for the Newton's second law of motion, it talks about the relationship between force, mass, and acceleration. In the second law of motion, Isaac Newton believed that force is equals to the total amount of mass multiplied by acceleration. So the amount of force needed depends upon the mass or the weight of the object and the speed that is required. It's just like pushing a 50 kilogram softball player. So the amount of force that you need in order for you to push a 50 kilogram softball player is the same with the amount of force that you need to exert when you are pushing a 50 kilogram box loaded with fruits or vegetables. Because even though the other one is a softball player and the other one is only a box full of fruits and vegetables, you still need to exert the same amount of force because their mass is just the same. So for Newton's second law of motion, we can use this magic triangle that will help us to determine what will be the formulas that we're going to use if the force is missing in our given problem, or maybe force is given together with acceleration but we're looking for the mass of the object, or maybe force and mass are given and then we'll be looking for the acceleration or the speed. Okay, so there are 3 possible options. Sometimes they're asking for the amount of force, the amount of mass, or the speed of the object. To sum up, we can use the following formula. We have force is equal to mass multiplied by acceleration. And while when we are looking for the acceleration, we can use the formula force divided by mass. And what if we're looking for the mass? So we can use the formula mass is equals to force divided by acceleration. I have here a sample problem. So allow me to read this our sample problem. How much force is needed to accelerate a 1,400 kilogram car with a total acceleration of 2 meters per second squared? So how can we solve this problem? Of course, first is to identify the given. So for you to easily answer the activities in your activity sheets, make sure but before solving or before trying to solve for the Newton's law of motion to at least jot down or write down all the formulas or the given in a problem. Okay, so let's take a look at the formula or the given rather. So for our given, we have 1,400 kilogram, which refers to the mass, while 2 meter per second squared referring to the acceleration. And then you have a clue there that on the first part of our question, how much force. So that already gives you an idea or a hint that the missing in the sample problem is the total amount of force. So here are our given. Mass, which is equivalent to 1,400 kilogram. Acceleration, which is equal to 2 meter per second squared. And then we're looking for the total amount of force that we need to exert in order for us to accelerate the car. Okay, so how to solve? The first step is to write our formula, followed by substituting of formulas. So F is equals to, so the amount of mass is 1,400 kilogram, multiplied by the amount of acceleration, which is 2 meter per second squared. You just need to perform basic multiplication. So 1,400 multiplied by 2 is 2,800. So our final answer is 2,800 kilogram meter per second squared or 2,800 Newton. Okay, so that ends the discussion for Newton's second law of motion. So we'll now move to Newton's third law of motion, which is all about the law of interaction. The law of interaction states that for every action, there is always an equal and opposite reaction. So it is an action-reaction basis, right? Wherein Sir Isaac Newton believes that for every action, there is always an equivalent reaction. Just like for example here, so the reaction is the recoil force of the gun. So what is the action? The accelerating force of the bullet. So as you can see, there is an opposite. There is an opposite between the reaction and the action. So your reaction is the recoil of the force of the gun, while the action is the accelerating force in the bullet. While on the second illustration, we have the action is that as we walk, our foot pushes down and back. So the reaction, so as we pushes down our foot back, the floor pushes up and forward, which makes us the ability to move, or which makes walking possible. Okay, so that ends our discussion for the Newton's 3 laws of motion. So to sum up, so I have here a summary of the Newton's 3 laws of motion. Number 1, an object at rest will remain at rest unless an external force is acted upon it, or an object will remain at rest or will continue to move uniformly in a straight line at a constant velocity with the same speed and direction unless acted upon by a force, and that is the law of inertia. Second, the rate of change in velocity of an object or in its acceleration is proportional to the force acting onto it. So what does it mean? So as we increase in velocity, there is also an increase in force. So more input energy to an object means more velocity. So what does it mean? Velocity and force are directly proportional. So as force increases, the amount of velocity or the acceleration also increases. Wherein acceleration, example of an acceleration is stamping harder on a gas pedal. So as you stamp harder on a gas pedal, there is an exertion of force. And number 3, if one object exerts a force, like for example, if your action is that you are throwing pieces of garbage in the river banks. So as you throw, in the long run, the reaction will be there might be floodings or landslides. So there's always an equal and at the same time an opposite. So it's just like positive and negative sign. There's always an equal yet opposite reaction. Okay? That sums up our discussion for lesson number 1 for Science 8. So let's move to our next discussion for lesson number 2. So for lesson number 2, we'll be discussing about work using constant force, power, potential energy, kinetic energy, and elastic potential energy. And here are our lessons objectives. 1. To identify and explain the factors that affect potential and kinetic energy. Differentiate the types of energy. Apply the factors that affects the different types of energy. Okay, so with that, let's move with the forms of energy. For our first discussion, I'll be discussing first about kinetic versus potential. So what is the difference between kinetic energy and potential energy? Number 1, kinetic energy is the energy an object has due to motion, which means any object or any individual or organism that is in motion possesses kinetic energy, such as meteors, walking, a man falling on the ground, a player throwing a ball, or a flying airplane. So there is a kinetic energy present in our examples, as you can see on our screen, which simply means that always remember that kinetic energy is a kind of energy that exists with an object, an individual, or an organism that has motion. So on the other hand, if kinetic energy is energy in motion, we have potential energy, which refers to the energy stored held by an object because of relative position, electric charge, or internal stress. So we have a raised object. So when an object is still raised and there is no further motion, that considered that the object raised contains potential energy. We also have dynamite, a drawn arrow, stretch spring, and a battery because they have chemically stored energy. So remember, potential energy is the counterpart of kinetic energy. If kinetic is an energy in motion, potential is an energy at rest. That ends our discussion for Science 8. And that will be the coverage of your examination for long tests and monthly tests, or what we call preliminary examination. Thank you and good day. God bless us all. Bye-bye.